Then we move on to model building and training. Basically, I imported basically I use sklearn to get like train split train test split, cost variance score, and k-folds and then to get like linear logistic regression, then to get the accuracy score, classification reports, and to import like standard scalar. So y is equal to df dot survive. This basically creates our target variable, which where we're trying to predict. Then we go on to x is equal to df dot drop columns such as survive, name, ticket, cabin, text, and x is equal to 1. Then we do standard scalar, which is scalar is equal to standard scalar. Basically, this standardizes all the feature. Then afterwards, we move on to x scaled equals to scalar.fit transform. Then s scaled df is equal to pandas data frame as scaled columns x is equal to now columns. Then we move on to the x train test x test y train y test, which is equal to the train test split of which is gives it, and which means we're basically training 80% of the data and we're testing it with the 20% of data, and then random state of 42. Then we move on to model is equal to logistic regression. The max iteration is 2000. Solver is equal to LBFGS. Basically, this creates like a logistic regression model with the parameters specified here. Then we do model.fit is equals to x train and y train. Basically, this trains the model on the training data of the 80% that we give. So yeah. Afterwards, we move on to y predict is equal to the model dot predict x train and accuracy. Then we print out the accuracy and the classification report within the data of like the y test and the y prediction. Basically, in this output we see that zero represents passengers who did not survive, and one like passengers who did survive. So the overall the test accuracy of this is like 80%, which is pretty high. And yeah, and then we see like the accuracy, the precision of the test, like for like people who did not survive as opposed to people who did survive. And we also see it for the recall, the F1 score, and the support. So yeah. Then we move on to the k-fold. So k alpha is equal to the k-fold and splits self-fold is true, random state. Basically, what this does is it creates like a k-fold cross validation splinter with five folds, allowing us to like get a reliable estimate of like the model's performance by basically testing it on multiple different like train splits. Then we do CV scores is equal to cross validation scores. Basically, what this is it basically performs the five-fold cross validation splinter. Then we basically print out all the accuracy score, the mean, average, accuracy, and the standard deviation. So these are like the accuracy for the five folds, and the overall accuracy of these five is like 80%, which is pretty high. And it gives us like the standard deviation for each, which is 3%. So that's also pretty good. Then we move on to the confusion matrix, by which I did by basically importing matplot lib.pyplot as PLT and import seaborn as SNS, and using sklearn to import confusion matrix. So CM is equal to confusion matrix, y test, and y predict. Basically, what this line of code is basically it calculates the confusion matrix by comparing the actual survival values against like the predicted models, the model's prediction, the y predict. Then we basically increase the size of this, and we use Seaborn to create a heat map. Then we label all of this, and then we show them. So the confusion matrix over here, it shows basically true negatives. Basically, it shows true negatives, uh, false positives. Then it shows false negatives. Then it shows true positives. So in our data, 89 of it is like true negatives. Basically, the model correctly predicted that these 89 passengers did not survive. However, there is 16 false positives, basically where the model incorrectly predicted that these 16 passengers did survive when they actually didn't. Over here in the bottom left, which is like false negatives, which like it the model incorrectly predicted that these 20 passengers did not survive when they actually did. And then over here in the true positives, the model correctly predicted that these 54 passengers did survive. So yeah. Then we move on to the coefficient for logistic regression. So feature importance equal to pandas out series model coefficient is 0, index x equals scaled to df dot columns. Basically what this does is basically it just creates like a panda series that contains like the coefficient of the logistic regression model. And then the feature imports sort variables values. What this does is it sorts all the coefficients and creates like a horizontal bar chart over here. Then we title it, then we label it, then we show it. Basically, in the chart we can see that variables like his female and his child has a large positive coefficient, basically reflecting like the policy of like basically allowing women and children to lead first, while basically lower P class 3, which is like the lower class of passengers, have lower negative coefficients, showing that people who did not have like high amount of income, who did not have enough influence, were like less likely to successfully like escape, as their priorities weren't like their priority wasn't at the top of the overall list. So yeah. Then we move on to making predictions on the test data set. So we're basically like filling in all the missing variables for the columns for age, fare, and embarked. Then we move on to like implementing binary features for like is female and is child, as genders, as one's gender and one's child were like one of the strongest predictors of like survivability on the Titanic, as women and children were allowed to evacuate first. So yeah. Then we move on to columns to encode, into which it has like calls with for loop calls in embarked and P class, if calls in test. Df is equal dot columns, if columns to encode is equal to test df, which is assigned to the pandas get dummies. Well, basically what this does is it basically converts the category of variables into such as like embarked and like P class into like binary indicator variables using like one hot encoding, as most like machine learning models can only work with like numeric inputs. So yeah. Then we move on to x columns is equal to call for call in x columns. If call is in test, df dot calls, x test submission is equal to test dot x columns. Was basically what's D2 code do is it basically only selects the columns from like the test data set that are used to basically like train the model, and this basically ensures that there is like consistency between like the training and the testing. So yeah. Then we moved on to x test scaled array, which is equal to scalar dot transform x test submission, and then x test submission scaled is equal to the pandas dot data frame, which it has given x test scaled array columns x text submissions dot column. What these two line of code basically do is it standardizes like the features by basically using the same scalar that was used on the training data set. So yeah. Then we move on to the test predictions is equal to model predict, which has the input of like x test submissions out scaled. What this does is that it applies the training model to like the process test data to predict like the survival outcomes. So yeah. Then we move on to submission equals pandas data frame, which has the passenger ID and the survived feature. Then we move on to submissions equals to pandas data frame, which has the passenger ID and the survival ID column, which then we will display by printing out the first four rows. Then we basically create like, then we do submission to CVS, and then we print out our our predictions for we print out our prediction and label it like Titanic prediction.cvs, and we compare it to the gender submission baseline over here, and we basically find the accuracy. So these are like the first 5 rows of like the Titanic prediction, and then it's basically being compared to the gender submission.cvs, as the accuracy of this model has a 94%. It's basically 94% um, accuracy compared to the gender submission.cvs. So yeah, that was the overall project for the Titanic dataset from Kraggle, determining whether a passenger survives or not. Thank you for listening.